So some time ago I had to go to a conference very much like this one, but the conference hotel had run out of room. And so I did what any sensible person would do. I went to one of these websites, in this case Orbitz. Now my conference was in Charleston, South Carolina, and Orbitz says visit planet Earth, but you know, I figure it should work anyway, right? So I go into Orbitz, I punch in my data, and I get a list of hotels back, and here's the list of hotels that I get. Now what I'm going to do is I'm going to put this window off on the side, all right? All I want you to remember from this screen is that there's two hotels. There's a Best Western and a Residence Inn, all right? Best Western, Residence Inn. Now I'm going to use shift click, right click, option click, whatever, to explore these hotel options a little bit. So here is the Best Western. I open it up and I look at it on my screen. It looks like a pretty decent hotel. But this other one, Residence Inn, Charleston, downtown Riverview, boy, that sounds really exciting. So I still have this window up on my screen. So I go down and check out the second hotel, and it's a good hotel, but I look at the room rate and I think, geez, I don't work for Microsoft. I'm just going to go with the Best Western, right? So I scroll down and there's a button there that says make the reservation, and I click on it, and sure enough, Orbitz makes my reservation for me. You've all had too much to eat for lunch. It makes the reservation at the wrong hotel. Now, you might think, well, this is an isolated bug on one particular website. Actually, it's a pervasive bug on Orbitz's website. It sent one of my friends on the wrong flight to Paris. You might think, well, that's just Orbitz. But let me give you a quotation now from a newspaper, from the New York Times. I'll just read this out to you, because I know not all of you can see the bottom of the screen. When I clicked on the national car rental price, the site responded with this message: you have back buttoned too far. This was my first experience with back button as a verb. Since that was patently untrue, I decoded its true meaning. We ran out of cars. Now, everyone here is a developer, so you know that's almost certainly not the true meaning of that message, but it just goes to show how badly screwed up things can be. In fact, my research group was recently contacted by a travel company, not Orbitz, that's been hit with a class action lawsuit because of the number of users that have been misdirected because of bugs on their website that are related to these kinds of navigational errors. So maybe there's a little bit of a problem. Maybe we don't entirely understand how to program interactive websites, right? Let's think a little bit about what it means to program an interactive website. So let's take an extraordinarily simple program, the kind of program you might, if you were teaching classes, you might teach in the first week to your students, or you might have written in your very first week as a programmer. All it's doing is adding two numbers, okay? On a console, I have this is, pick your favorite language. You can translate this into your favorite language. I have some mechanism by which I can read a number, read a second number, print out the sum, and print out, stop the program, right? Completely straightforward. There's no tricks on screen, I promise you. Now, I would like to write a similar program that runs on the web. Now, obviously, I can't run exactly the same program. Something's going to have to change a little bit, okay? So, for instance, instead of using strings, I'm going to have to use some HTML forms to present the information to the user, right? So, I have this represented here symbolically by putting little pointy brackets. That's how you know I'm talking HTML, okay? Also, I'm getting input not from a keyboard or from a database, but from the website, right? So instead of read, I have something that I'll hypothetically call read sub web, okay? It's how I read input from a website. Questions about this program? Make sense? Perfectly straightforward. You'd like to be able to write this in your first week and get it to run, okay? There's a little bit of a problem. The problem is known as the statelessness of web servers, right? What happens how many here have not written a web application at some point? Wonderful. Just my perfect kind of audience, okay? So you all know this. You write out some kind of output, and then the program terminates. Why does the program terminate? I mean, that's really stupid. Why would you keep stopping programs? Why does this happen? That's all about scalability. I was going to say it's the S word. The S word is statelessness, but the real S word is scalability, right? Because not everybody who starts, well, I'm sure every one of you, when you start an interaction with Amazon, do go all the way through and buy the book that you started out searching for. But I'm told there are some people in the world who don't do that, right? So this is why we need the statelessness on the web server. We need to be able to scale applications. So mechanically what happens is this. We get to some point of interaction, the program terminates, which you can think of as the stack being erased, and at some point some other program needs to come back and resume the computation, okay? Restore the stack. So what ends up happening is this program that looks very compelling and very straightforward can't actually run. The moment I produce the first form, the rest of the computation, which is take some output, assign it to n1, print out the second form, assign it to n2, and then print out the final answer, this is all completely wiped out. It's lost. It's just gone, whoosh, out of the server, right? This is what the CGI protocol and related protocols do. So what I really need to write is quite a different program, and you all know this because you've written this kind of program many times, and it's incredibly annoying, right? What you write is not actually one program but 3 programs, and there are lots of hidden dependencies now between these different fragments of code, and each of these hidden dependencies of course is just another mistake waiting to happen, including all this wonderful stuff like hidden fields and la-di-da, right? Anyone here not programmed with a hidden field? Good, perfect, even better audience. So the programmer has to track all of these dependencies, and it's really annoying when you make a mistake, right? In fact, if you make just the right kind of mistake, you can turn a statically scoped program into a dynamically scoped program, right? And if there's one idea we can all agree upon was a really bad idea, it's dynamic scope, except William Cook. So, is that a question?
No, can you stop shouting?
Oh, I'm sorry. Okay, so maybe you can turn the volume down. I can't turn my volume down. Okay, I'll stop shouting. Can you still hear me at the back? Apparently you can hear me just fine. Thanks, Will. Yeah. So the question, by the way, was, can you stop shouting? You wanted all questions. Remember that. So we want to not have to write these programs. So what we observe is the following, what several people have observed, is that, remember the grayed out part, you can see from the back that some of the stuff is gray. Okay, the grayed out part is the computation that was lost. Now let's say we could miraculously resume the program somehow, just miraculously, okay? Resume the computation. What would happen is we'd produce the second form, and then we'd run into the same problem again. And this grayed out part would be what is lost, right? So we keep getting this rest of the computation that keeps getting lost. Now the beautiful thing is, we have a name for this thing. We have a name that precisely captures the grayed out piece of code that is being lost every time we run the program. This is that horrible, evil thing called the continuation. Okay? Yeah, Jim and others are supposed to boo and hiss right now. Where's Gilad? Gilad, give me some love, man. Okay, it's a wonderful thing, it's just useless. Okay, good. All right. So this lost computation is the continuation. So if you want to know what the continuation is, a good simple mental model for the continuation is the grayed out stuff. It's what's waiting to happen. Because what is the stack? A stack is simply a record of the computation that's waiting to happen, right? I mean, people sometimes get a little confused about this, right? The stack is not where you've been, but the stack is where you're supposed to go. So if the stack is erased, that's exactly recording where you're supposed to go, and that's exactly what's being lost. Okay? Now, actually, it's not quite so simple as just the continuation. What programmers have been doing, and we've actually studied a lot of web programs to check this, what programmers are doing is manually simulating composition of a bunch of things that we understand quite well. One is translating the program into what we call continuation passing style, that is making all these rest of the computation explicit. Then there's something called lambda lifting, lambda, bad word, I know, sorry. Okay, lambda lifting, which is taking all these things and pushing them to the top level because otherwise the server can't re-enter them. And then there's something called closure conversion to avoid you from losing all the free variables and whatnot. And what you as developers now understand is that academics must be a bunch of world-class ninnies because they have all these fancy names for something that you know how to do by hand. Okay? Well, it's true, academics are a bunch of world-class ninnies. But the fact of the matter is, these are transformations that we understand really well. In fact, it's even more interesting than that because these have all been inside compilers for about 25 years now. We can even talk about proving that they are correct. So we could conceivably write a compiler that does this for us for free. That is to say, take the program that was on the left-hand side of the screen, the one that we wanted to be able to write, and automatically transform it into the program on the right-hand side of the screen, which is the one we don't want to have to write and certainly don't want to have to maintain, right? We could get the seamless integration between the two sides, and this would be very straightforward for a compiler to do, and I and probably others in this room have written such a compiler. And we can even, if you so care, prove such things correct, but we certainly don't want to do that after listening to talks this morning. So, what you should be thinking about as an end user is not all this semantics and correctness and all this other stuff. You should be thinking, I want a better API. All this boils down to a very simple statement, right? I want an API that has an operation like this in the API. And then it's somebody else's problem to figure out how to implement it. In fact, specifically, it's Eric Meyer and Jim Miller's problem to figure out how to implement it, right? Make it their problem. They are very smart people. They can do this for you right and do it once, and you never have to think about it again. As programmers, you should be standing up for your rights, because think about what your web APIs do give you. They give you the most mind-boggling assortment of functions that manipulate strings, right? Make a cookie, delete a cookie, add a cookie, strip apart a cookie, parse a cookie, la-di-da. We can write those ourselves. This is the part that we need to get some true heavy lifting in our APIs. Question or comment?
Well, Shriram, doesn't this all boil back to the browser? I mean, we need to rebuild the browser. The browser needs to be rebuilt. It wasn't designed to do things that we're trying to do with it today.
Okay, so the question was about browser. So the argument is that the problem lies in the browser because the browser is being made to do things it was not designed to do. I would disagree on two counts, okay? So, okay, you're right. You're absolutely right. We could imagine, this is my first disagreement. He's absolutely right.
You have to learn at least four different protocols or languages just to do web development.
Right, so the argument, well, so that's, okay, so the comment was, that's why we have to learn all these protocols and languages. I'm going to argue that that's an orthogonal issue. Let's get back to the first point, okay? We could re-engineer our browsers to do what you want. That is to say, when you submit a request to the server, it just keeps a connection open and doesn't go away, okay? It just stays alive, and then the browser program keeps running, the client program keeps running, the browser keeps the network open. The problem is you will rapidly run into the difficulty that there's only so many network connections you can keep open.
But that's just one technique on rebuilding the browser. I'm not saying
the problem is entirely on the server side, though. If you're willing to make the protocol stateless, then it has to be dealt with on the server side. It can't be a problem on the browser side. The browser is powerless because statelessness means you make the connection, you stop, and you're done. The browser has no further say in the matter. It has to be dealt with on the server side.
But, well, I guess I just feel that there are additional constructs needed on the browser side. I mean, you're right, it is brain dead.
So, okay, good. That's all. We've reached our agreement then. It's brain dead, and that's really the point I'm trying to make here. Okay, is that you would want a better API, and I'm telling you a little bit about what that API might look like. The details of how we implement that, as I will point out in the next slide, we can argue quite a bit about how to do that. Okay, question, sir.
Basically, my comment is maybe it doesn't have to be one or another.
Uh-huh.
It can be both. Maybe we can design a technology that can be stateless when it needs to be and stateful when we need it.
So the comment is maybe we can design a better technology that's stateless when necessary, stateful when we want it, and
instead of attaching basically the whole hairball,
yeah,
basically, which is HTML, HTTP, and CSS, and you name it. Maybe we just need to look at the problem again and find something that is really going to score right.
Okay, so the argument is maybe we should revisit our foundations and think about a better solution from scratch. So what I find very ironic is I'm the academic standing up here and I'm talking about embracing existing standards, the fact that there are millions of browsers out there, et cetera, and I have a bunch of people from industry telling me, no, we should do a nice academic exercise which is start all over again from scratch.
Yeah.
This is lovely. This is absolutely delightful. Yes, I agree. If you could actually get, in fact, there's an easier solution than that, right? We could just tell Microsoft to implement the better API. Once they do it, then the distinction between an industrial standard and adoption, all these arguments sort of go away, right? So that's one alternative. Back there, sir. So the argument here, counter argument is the internet is what it is and we've got to live with it. Okay, so I'll tell you what, you guys should meet up after the for the next break and hash this out. I'll go on with my talk for now. How's that? Okay? Other questions, comments? Yeah, good. All right. So there are different ways of implementing this. One, as I said, is we can have a web compiler that basically takes the program on the left and compiles it into the program on the right, splits up the program, generates the forms, preserves behavior, proof theorems, la-di-da. The other approach is we can actually get direct support from a combination of the programming language and the web server that you're running on. Okay? And my research group has explored both of these options in quite a bit of depth. What I'm going to tell you about is not the implementation technology per se for either of these options, but to try to give you a feel for what it's like to program when you have this better API. I want to give you a few quick examples of that feeling, okay? Because I get pleasure out of programming this way, and I want you to understand why. So I'm going to tell you what it's like to program in something called PLT Scheme, which has a programming environment called Dr. Scheme, okay? But I know that the more it's sort of like the Stephen Hawking thing, right? Every equation cuts your readership in half. Like every parenthesis on screen cuts your viewership in half. So don't worry, this is a parent-free zone, okay? There won't be any parentheses in this talk. You have to just imagine your own parents. So first I need to tell you that I've lied a little bit. Don't rush out and implement read web because it's not the right API. As you all know from programming on the web, when you write an HTML form, you have to stick something in the action field. Otherwise it doesn't do anything, right? You click submit and nothing happens. And I've been pretending that there's something called read web, but I haven't told you what to put in the action field. So the actual API is a little different. It's something called send suspend. Okay? Stands for send out a computation, send out a page, and then suspend the computation. Conceptually suspend the computation. Now, send suspend is a binding form. Okay? It binds something to K, which you can then use in the body. It binds a value to K, you can then use K in the body. For example, you can put K in the action field of a form, in the action field of a form. Okay? So send suspend is going to generate the URL that is necessary to resume the computation. You'll see lots of examples of this in just another moment. Okay? Let me give you an idea of what these URLs look like. They look kind of like this. Okay? So there's some host, there's some servlet that you're talking about, and then a bunch of gobbledygook, which is meant to, the gobbledygook includes a few things like there's a little bit of crypto information, there's liveness information. Essentially think of it as an unforgeable URL. Okay? And it'll actually be relevant, the unforgeability will be relevant in a moment. Right? So it generates URLs like this. So what that means is the previous program that we wanted to write, this is essentially the program. I say send suspend, generate me one of these K things. I'm going to stick it inside the form, and I put out a form that says enter the first number. If and when the user ever clicks the submit button, computation will return right over here, bind the value to N1. Okay? So one of those URLs represents this gray region. Now when the user provides an input, that value goes to N1, you get a new URL. Okay? That value goes to N2, you provide an answer, and it actually prints out the answer. Okay? So when I'm interacting with it on the web page, if I have a page that looks like this, that enter button is effectively bound to that URL there, right, through the form. When I submit, I get a new page, and it's bound to that. But the important thing is that the continuation is statically scoped, which means it remembers the value given to N1. This value that I enter down over here is remembered by the continuation. That's just what they do. You can't help it. Continuations will remember statically, lexically bound variables. So it remembers the value of N1. So you don't have to create a hidden field and figure out how to marshal it into your store, etc., etc. It's just remembered for you, and now I can print the answer and I go home. Eric. If that, okay, so Eric's question is, what if it's a mutable variable? If it's a mutable variable, you get a reference to it, but not the actual value. So in fact, what we can do is we can understand the problem with the orbits example I put up at the beginning as being precisely that. If they had made it immutable, it would have stored the value of the hotel. Because they made it mutable, it stored a reference to the hotel, and one hotel choice interfered with the other hotel choice. So the nice thing is, by understanding a little bit about continuations, we can precisely capture the distinctions between these different kinds of information flow. Okay? Good. So we've done a little bit more than just add numbers, in case you're wondering if this talk's ever going to get to more interesting programs. In fact, my job search in my university this past year was run entirely using our continuation-based web server. So we do actually put our money where our mouth is. We've also been working for several years now on a conference submission manager. So imagine a conference like this, you submit papers, people write reviews, etc., etc. And several conferences have used it, and some even pay for the prestige and value of using it. And it's called Continue, okay? And this is, I'm not going to show you a lot of the Continue code because Continue has the following wonderful property. It's a really boring program. Now, why am I proud of this? I'm proud of this because it's just basically one big functional program, okay? There's nothing exceptional about it, and you could, if it were meaningful to, you could just as well run it on a console and you wouldn't notice a difference. It's just a big old functional program. If I need to write an abstraction where I go off and get a value from the user, I can do that. I can do maps and filters and folds, all of these over functions that interact with the web, and I don't have to twist all of their structure back around because I need to interact on the web, right? This is the beautiful thing about this program. It's incredibly boring. William.
Well, since you mentioned it, I guess this is the part that I'm not sure I buy, is that I'm not sure I want to have my web app be, or to think about my web apps as console applications. And you seem to have managed how to get console applications to web apps to look like console applications.
So Will says he doesn't want to think of his web apps to look like console applications. I'm going to argue, do you want to respond to that? Do you want to comment on that?
I think from the point of view, I would think of neither one, neither the other. I just want to let it out. I don't care what I mean, that's what I would tell you.
Okay, but I'm saying in terms of the metaphor of the user interface, I'm not sure a console app is the one that I...
Okay, so the argument here is whether we should think of a web app as a console app, and I'm going to argue that I'm using the word console app more to make a rhetorical point than anything else, okay, which is that when I think, what I want to be able to do is to reuse what we know about structuring programs that we've studied for 45 years, okay, starting in about 1960, okay, and when I use the word console app, for me the word console app is just a shorthand for the way we've studied how to structure applications. And that way of structuring applications is to think of programs as functions that consume inputs and produce outputs. And web applications pervert the style of the program and invert the style of the program. And that's what I'm trying to combat. And console is perhaps an overloaded term for that, a very strongly loaded term for that. Eric?
Is it maybe another way of saying that you want to write a program that maintains state across interactions with the user?
Yes, so Eric's comment was, do you want to think of it as applications that maintain state across interactions with the user? And that's absolutely what I want to do. And I want to do that without that being a completely different style of program than one that doesn't do that. Yes, Roman?
Yeah, but actually, just last thing you said, that actual web applications, they change this model that you used to, like functional, we consume input and produce output. I would argue, but what about normal GUI applications?
Hold on for about, can you hold on for 5 minutes? Can you hold on for about 5 minutes? Good, okay, thank you. So let me show you one, we're going to get back to that point, okay? So let me show you an example of a program that we would want to write over here. Okay, so this is what the screen looks like. It's just another web application. So here's our scenario, okay? So we have our little absent-minded professor here, okay? And the professor wants to submit a paper to the conference, and the last thing you want is to have an unauthenticated email address because it's just a nightmare. You send out reviews and there's email doesn't work and whatnot. So you want to have the following dialogue. Professor says, please register my email address. You want the server to come back and say, okay, but only if you visit this URL. The professor visits the URL, and the act of visiting the URL says, okay, you're authenticated, I know who you are, now you're registered. Okay? Now, this has nothing to do, has anyone ever seen such a program before? All right, okay, this has nothing to do with conference management, right? You want Yahoo and all sorts of people, Microsoft, everyone makes you go through this sort of rigmarole. So this, by the way, depends on this URL being essentially unforgeable, right? So that ties back to what we talked about earlier. So let's write the program. So the first part of the program is incredibly boring, okay? I create a form, I say, please enter your email address, and I get back the email address, and it's bound to the variable address, okay? Nothing surprising. Now I'm about to do something a little different from what you've seen before, so pay attention. So when the user clicks submit, that value gets bound to address, and now we go to the rest of the computation. Now I'm going to call send suspend, but I'm going to ignore the return value. Watch. Okay? I call send suspend. That generates a new K, a new URL. I send that URL in email to the user in the email address that they gave, and I print out a little message on the screen saying we sent mail to this address. If it's wrong, please hit the back button, go back and fix it and submit again. But we don't give them any way of continuing the computation on the screen. There's no form, there's no submit button, nothing. The K only goes through email. What is the continuation? It is whatever comes next. Well, what comes next is whatever goes in the gray box, okay? But at this point, what's the only way they have of resuming the computation? It's by being the actual recipient of that email message and clicking on that link. Therefore, the very act of resuming the computation tells me what I need to know. I've authenticated them, I add them to my database, do whatever. Okay? This is, I mean, other than the parentheses, this is the actual code. Okay? And we can build abstractions over these, like doing this in a loop if things go wrong, if the address is not quite right. These things, and it's completely natural to put things in things like a loop. Here's another scenario. Okay, so I have my professor is asked to do a review. As some of you know, professors don't do very much work themselves. They get their grad students to do all their work. So we have a nice facility where the professor can submit where the reviewer can submit an email address and say, please delegate the review to this person. So the person submits a review, but you don't want them to submit a review more than once, right? Because the student might submit a review and you might say, oh, that's a really harsh review, let me tone it down a little bit. Then the student comes back with that URL again and submits another review, and you don't want to get into a war over there, right? So you want to have a policy that they can submit a review only once, and after that the continuation they receive no longer works. Okay, here's the code. So this again looks very natural, create a form, generate a URL, etc. But instead of send suspend, we have something called send finish. Send finish says, once this URL is used once, the URL is then discarded, you can't use it again. Okay? And we have a whole menagerie of operations like this. We have send forward, send back. So for example, if you build a credit card website, I've certainly had the experience, the act of printing the credit card receipt ends up submitting the URL again, runs up redoing the previous computation, which ends up charging me for a second year on the domain name server. Okay? I've had experiences like that, and you probably have too. So what you want is, as a programmer, to be able to, well, maybe if you run a domain name service, what you really want is to charge people as many times as possible. But assuming that you didn't want that, you want the ability as a programmer to restrict the lifetime and the usability of these continuations, to be able to say, you can only go forward from this point, you can only go behind this point, you can't do anything else at this point. You want to be able to say that. We have a bunch of operations for doing that. Okay? Now I give you a choice on what I do in this talk. I can either go off and talk about continuations more, or I can tell you about a brand new programming language that we've been designing that gets to some of these questions, such as functional programming and GUIs and so on. So you get a choice. Which one do you want?
Or the language conference.
Language conference. So you want to see the language. Language? No, this genuinely is a choice. You get to pick. Language? Language. Can you capture the continuation and come back? The problem with that is there's not enough time in the schedule for that. Good joke though. Besides, it's Microsoft. I mean, schedules really mean a lot here, right?
I asked, why are you saying it's web specific? Normal GUI, user clicks the button, we do something, change the state.
Yep.
In wizard.
Yep.
And win the stack again.
GUIs have the same issue. GUIs have the same issue, and what I'm going to try showing you is my approach and a solution to that problem too.
So it's
Okay.
not web specific.
It's not web specific at all, but I want it to work in a specific context. Okay, so let's talk about GUIs. All right. So what you really want to know, I should hope by now, is okay, all this web stuff is fine, but we've heard from William Cook and we've heard from Gilad Bracha about how all this continuation stuff is complete rubbish anyway. It's useless. So we should all be moving to Ajax. So if we should be moving to Ajax, I need to be able to give you an Ajax story as well. So what I'm going to do now is give you my Ajax story. But Ajax is a big complicated thing, and there's a lot of details here. So to make it very concrete, let me instead shift the agenda a little bit. Let's talk about Eric Meyer. Okay? So, Eric Meyer, before he came to Microsoft, spent a large part of his life in a completely useless occupation. Okay? Spent all of this time doing this Haskell, functional programming, declarative stuff. And it's pretty obvious this is a totally wrong-headed, failed idea, right? That's why he's here at Microsoft trying to make a living instead. But, you all know I mean, you all know this, right? This is a total waste of time. You know that instead the way to be building applications is not through all this functional stuff. The way to be doing it is by using model view controller. This is best practice, and you all know this. Okay? Now, if we think about this a little bit, it start wondering a little, I mean, what is a model? Isn't a model really like a declarative specification of the... It's best not to ask these questions too much. Let's not go there, okay? So, forget I even asked that. Yes, besides, all this functional stuff is bogus, right? Because the world has changed. It has state. And functional programming has no clue about state. If you've ever seen a monad, that is to know what true pain and suffering is, okay? If that's the best answer these functional guys can give us about state, they deserve what they get and more, right? So functional programming is obviously not a very good idea. The world is inherently stateful. Do you have a comment, question? No. Okay, all right. So, yes, good. See, even the audience knows that this stuff is useless. So, let me give you a few examples of state, all right? So, let me just point out there's something as sort of natural state and there's artificial state, okay? When you create a variable in your program and mutate it, there may not be a particularly good reason for doing that. That could be artificial. Okay, that could just be you don't know how to program better. You haven't been introduced to maps, filters, and folds. That's your problem. But then there's state that you don't have any control over. For example, what is the current position of the mouse? Well, it's constantly changing, right? As I keep moving my mouse around, that position keeps changing. Or what is the sequence of keystrokes I've seen so far? That sequence is a stateful value that keeps growing over time. Or if I have a user, if I have some way of querying where the user is moving around. Or the sequence of network packets that I've seen so far, or the status of the mode keys, or the sequence of mouse clicks, or for that matter, the current time, right? These are all stateful values that keep changing over time. And if I don't have a programming language that will let me naturally capture programs over these domains, I don't have a very useful programming language. So, what we have in a model view controller is the following kind of layout. We've got a bunch of sources of information. They affect our model, and the model in turn affects the views. So something happens. There's some change over there. Okay, for those of you who can't see at the back, I just put a big flash on my keyboard. Okay, that turns into a big flash on the model, which in turn has to propagate the information all the way back to the views, which, needless to say, might lead to a cycle by causing another change in the model, in the inputs again. Okay. This is what happens when you program properly with model view controller. And this is why it's not very meaningful to say the model is a functional declarative program, because it's constantly operating over stuff that keeps changing. Okay?
Excuse me, are you using this concept of model view control in the sense of object-oriented design? Because you're talking with model view control, then you're talking about functional programming, but model view control doesn't really have a meaning for functional paradigm.
So the question was, am I talking about model view controller in the context of object-oriented design, because model view controller doesn't mean anything in the functional context. I'm talking about model view controller, right? This picture has no functional or object-oriented code anywhere on it.
Yeah,
it's an independent concept.
Yeah, but if you're in Haskell, I never heard of anybody doing
I agree, the Haskell guys, this is the problem. They don't have a clue. Don't worry about the Haskell guys. Yeah, they're all, but I just trashed all these functional guys, so why are you asking me to defend them? Of course we're in an object-oriented world. Good. Objects.
Actually, the question is what we see in the picture, is it imperative?
What we see in the picture is a very imperative program, right, William? You should be happy, right? It's extremely imperative. Stuff is changing all the time, and we have to keep responding to changes in stuff. So let's talk a little bit about programming style, okay? How do we program these silly things? Are these erasable markers? Those don't look erasable. These are erasable, okay? How do we program these things? We program these things with callbacks. Obviously, right? That's the way to program. You have to use callbacks. Why do we use callbacks? Because we have stuff at the bottom, right, that's flashing and sending stuff up. So we need to install some code over here so the keyboard or the mouse or the network or whatever can tell us something changed, you need to respond to it. And then that propagates all the way up. Well, there's a problem with callbacks. What is the type of a callback? What's the type of any callback? What is the return value of a callback?
What kind of type system are you talking about?
Oh, make up your own. It doesn't matter. They don't have anything interesting to return because callbacks are domain independent. Okay? The program is sitting over here. The keyboard is sitting down here. The program doesn't have anything interesting to say to the keyboard. It's the keyboard that has something interesting to say to the program. So if we look at some actual callbacks from Gilad Bracha's favorite programming language, we see that they all have return type void because there's nothing interesting to return. If there's nothing interesting to return, well, if they return void, we can't compose them. So if we want to think of the world as programs being a black box where inputs go to outputs and the output is a function of the input, you are hosed because everything is of type void. You can't think of the output as a function of the input. That's what callbacks put you in. So we should think about this a little more. The alternative is to say, well, when there's a change, the problem was propagating the change through the system. Why not make that the programming language's problem? I mean, if we're going to do this over and over and over again, well, the last time we had to do things over and over and over again, we made it the language's problem. Garbage collection, closure creation, etc., etc. That's what languages are supposed to do. Take things that we do over and over again and build them into the darn language. Okay? So if you remember the slide I had on state, you'll notice there were actually two kinds of state. There's stuff that I call the current x, whatever x is, and it always has a value. And then there's sequences of x, which is a potentially infinite sequence. There could be an infinite number of mouse clicks, but I don't know when the next one will come. So here I can always look at the value and I get an answer. It just may change after I've looked at it. Here, I can't poll for a value. I have to wait for the value to get pushed to me. So I call the things on the top behaviors, the things at the bottom event streams. Potentially infinite streams of events. Okay? No functional programming. We're just talking about callbacks, good object-oriented stuff. Okay? This is how you're supposed to program. No functional crap. Okay? So I want to tell you about our new language called Flapjacks. So Flapjacks has a bunch of ideas, and I want to run very quickly. Don't worry, I won't run out of time, Jim. The first idea in Flapjacks is the following. What is the DOM? Everyone here has programmed JavaScript, Ajax, all this stuff, right? I mean, you generally know what's going on. What is the DOM? Well, so it's a value that's available in JavaScript. Whenever you look, there's a value available, but that value may change over time. You may change it or something else may change it and you observe the change. Well, gee, isn't that kind of the same as the current position of the mouse or the current time or any of these other things? The DOM is just a behavior. So, let's see what programs in Flapjacks look like. Okay? I am going to start by actually running some code, and then I'll show you the code that I'm running. So here's this program, and as you can see, as I move my mouse around, I hope the people in the back can see I'm moving a mouse. As I move a mouse, you see the coordinates are constantly changing. Now let's look at the code that goes with it. Okay? I'm going to show you the code line by line. So at the top, I say script language equals Flapjacks. Okay? What's running on my browser is actually honest to goodness JavaScript. I mean, you saw it running, right? It's JavaScript. But I write the code in a language called Flapjacks. And here's what's going on. Here's the body of my document over here. It says the mouse's coordinates are, and I have, less than the little pointy brackets, and I have two IDs, two cascading style sheet IDs. One's called mleft and the other's called mtop. Okay? So if I had no JavaScript on this page, you would just see something that says the mouse's coordinates are not initialized. Okay? But now let's go up over here. What I say is I want to insert into the DOM a behavior which corresponds to the mouse's top position behavior, which is built into the language. Okay? So I ask for the top position of the mouse, and that's a behavior. And I want to insert that into position mtop, and likewise something at the mouse's left position behavior at mleft. The idea is that this creates a data flow graph. The act of inserting these things creates a data flow graph. So every time the mouse changes, all the expressions that depend on the positions of the mouse automatically recompute. So the problem with state is the functional guys were all wrong. The problem is not with state. The problem is that you have dependencies on state, and if they're not kept consistent, everything breaks down. State is not the evil thing. So here, the dependencies on state are kept up to date automatically. Let me show you more examples to show you how this works. Okay? let's take another simple program. I move my cursor around, okay? And you can see that there's a little box that moves around. Okay, let's look at the code. So, I insert into DOM a behavior. I'm saying I want to insert a time varying value into the DOM. Okay? It's a div tag. The B is just says behavior at the end. Color, background, all this stuff is standard. The left position of this is the mouse left B. The top position is the mouse top. And I want to insert the text the mouse. And I'm inserting it into the body tag at the beginning. Okay? So I insert into body tag one of these time varying values so that every time the mouse moves, the value automatically recomputes. Notice there are no callbacks anywhere in this code. Okay? I just express a dependency. I'm describing a model, a declarative model that expresses a dependency, and it's the language's job to keep things up to date. So here's a slightly more interesting case of a mouse. You see I have a mouse, and this mouse now has a tail. So as I move the mouse around, thankfully its tail comes with it, but with a little bit of a delay. Okay? So here's what it looks like. This part looks exactly the same as what I had before. The left position is the top left of the mouse, the top is the top of the mouse. But now the mouse's tail is delayed by some constant, in this case half a second. Okay? It's wherever the mouse used to be half a second ago. And it's top, and then I take this, I add the offset of the size of that box, and that gives me the current position. Okay? So I don't have to write a callback, I don't have to install a timer, event, and all that other stuff. I just say that it's offset by half a second, and now it follows the behavior. Okay? And I can do some cute stuff like I could add a mouse, and I could add its tail, and I could add a little randomness to the tail, and as you can see, the mouse can then wag its tail for me. Okay? But enough with mice. Let's do something more interesting. Here is a program that shows me the current time, right? System Java's millisecond timer. Okay? The code is very simple. I have some HTML. I've left a cascading style sheet ID here called timer. And now in my script I say, make me a timer behavior, right, that updates every 100 milliseconds, and insert it into the DOM at the position timer. Well, so far I haven't shown you any deep dependencies, right? I haven't shown you stuff really depending on each other. Let me show you some stuff that depends on each other. So let's take a different program where I have the original timer that I had before, but now I'm going to divide it to get myself a second timer, right, that counts up every second, and then computes the time seconds modulo 10. Make sense as a program? Okay, let's look at the code. So, like before, I give myself a little bunch of CSS tags into which I want to insert stuff. Notice, by the way, that I'm getting this very nice separation between the HTML and the JavaScript. So I have a working HTML page without any JavaScript. All the behavior gets added in as advice from the outside rather than commingling my view with the behavior that I want to have go with it. So here I create a timer.
Excuse me.
Yes?
But most people would consider putting your business logic within the presentation not necessarily a good thing. So most people would be taking the script out and putting on the surface.
Yeah, but the point is I have achieved the separation between the view and the script. Where I put the script is entirely up to me now, right? I mean, if I don't show you the source, if I said everything's on the server, you'd say, well, I can't see it. That's why I've put it inside the file.
But is there any way of taking the script and printing out?
Yeah, you could have a reference to a file on the server.
It's because you started your presentation talking about state from time to server, situations and stuff like that.
Now I'm talking about single page applications. I'm giving you Ajax single page applications. Okay, we'll get to the Ajax part in a moment. Okay, I'm not done yet. Okay, so now look at this. What I do is I take the timer B, I divide it by 1,000, I take the floor, and I insert that. So what that does is that creates a sequence of data flow nodes. So I have timer B at the bottom, okay? And that feeds into something that divides by 1,000. Okay? And that feeds into the floor function. Okay? And so on. Every time this updates, this updates, this updates, and the whole thing updates all the way through till eventually it shows up on my screen. If this never updates, this never updates. So I could, if I had time, bring up my system performance monitor and so on, and you would see that even though I have I have a microsecond timer almost, this thing only updates once every second. It doesn't perform any unnecessary computation. Okay? And likewise over here, I'm taking this and I'm doing the modulo operation, which builds up another node on top, and it propagates all the way through. So I could do more complicated things. So for example, I could take a list whose content and size depend on the time. And I could print that out on screen, okay, very easily by just saying, I have this just as I had before. I write a function that says 1 to n, just make me an array of all the numbers from 1 to n. I write another function that's array to string. This is all totally generic JavaScript. There's no reactive stuff, anything going on, okay? This is JavaScript you already know how to write, right? But now if I call this function from down here, which is, I say make me something from 1 to n of time mod 10 and call array to string on that, because this thing changes every second, this thing changes every second, which means this whole thing changes every second, and I just get this data flow graph. And what I'm doing here is I'm expressing the model, and I'm leaving the view separate from the model. I just describe where it goes into my page, and it automatically goes in there. Okay? I'm going to show you one other demonstration. So this is, how many of you know what Delicious, how many of you don't know what Delicious is? It's a website, basically think of it as a glorified web-based bookmark facility, okay? So I can go into Delicious and I can type a username, okay? Right? So as I type letters, it keeps giving me back the value of the Delicious lookup. So what I do over here is I have a mechanism for doing cross-site scripting, which is evaluate a foreign script and return the value, but that's another event stream. So every keystroke over here, okay, what I do is I go, I'm at the top. So first I have that box where I type things in, and I turn that into an event stream. So every time somebody does a change or a blur, I turn that into an event, okay? And then I extract the value of the username field by pulling the value out of it. So that gives me an event stream of the values of that box. So every computation where I now use username change also becomes one of these computations that updates every time something changes. So every time I type a new keystroke, this goes off over the web, runs the cross-site script, pulls down the Delicious bookmarks. Okay? And then I just do a little bit of formatting and I print it out on the screen. And again, as you look at the screen, as you look at the HTML, I just have a CSS ID. I don't have any fancy code, any JavaScript code sitting in there. I have this clean separation between the view that I want to achieve and the code that accomplishes the view. Okay? And just one last example of this. The Delicious demo is kind of annoying because every time I type a keystroke, it sends off to the server, and so it's sort of a flickery experience. So instead, I could come up with a slightly different version where I type something and it waits for half a second, and only then does it go to the server. In fact, I could do something even better, which is it only goes every half second, okay? But then it comes back and gives me an abbreviated version of all of my links. And as I mouse over them, they expand into bigger links. You see? And the code for this is really surprisingly simple. All I did was I called this function com, which says wait for 450 milliseconds, and only if it changes in 450 milliseconds do you issue a new event. Otherwise, don't issue another event. Right? This is exactly what you want. You want to be able to say, Pause for 450 seconds. If nothing changes, then you turn it into an event. Otherwise, don't turn it into an event. That's what CalmE does. Okay? It filters out the repetitions, and I get a calm, smooth behavior. And now I just merge these. Well, I can show you the details, but I'm running out of time. Okay? But that, at a high level, is what I get by turning the DOM into a behavior. I can look at things in the DOM. I can say make an event stream out of something in the DOM. Every time that changes, I get to see it. Every time I change it, the change goes back out. So the second idea in Flapjacks is to give you a worse syntax. Okay? What I've shown you is a very nice functional syntax where function composition works exactly as you want. But what we also have is a data flow syntax that you can program as if you can just program this in pure JavaScript. You don't have to use this fancier syntax. You can just think of it as a JavaScript library. So what we actually have is a compiler that'll take something like this and turn it into something like this, and I've underlined the parts that changed. But you don't have to program with the compiler. It's a function of what kind of design flow you have. You can just write code in JavaScript and you'll get all of the behavior that I showed you. So what I ran on my browser and connected to the web and so on is pure honest-to-goodness JavaScript code. So I told you a lot about leaving the view alone. There are two other ideas, and then I'm going to finish up. So the first idea is we want persistence, and we want persistence for free. Well, it's hard to tell what persistence for free means. We're all used to programming with an external database, but it's kind of nice because lots of programs can share data, but it's really messy because we don't get this nice integration with the program view model where I've got these nice objects. Then people have done research on persistent stores, which are great for programming simplicity, but they make these closed world assumptions. So what Flapjacks gives you instead is a synthesis of the two, where when you're programming your script, you honest to goodness get a persistent store, but there's also an API with database semantics so you can access the data from the outside. Finally, we have a security model for the language. What we're targeting is applications like Google Spreadsheets, Writely, Google Calendar, and so on that enable very easy sharing. So the idea is all the values live inside something called a security domain, and the security domain is what grants privileges. So I want to share something with Eric. I give this security domain has privileges for Eric, and all of my spreadsheets that live in there, Eric can automatically share. Every operation in the language automatically does access control. You don't have to build it in. You don't get a choice in the matter. Authentication is a linguistic primitive. I mean, just think about it, right? What's an authentication box? It's two behaviors for boxes, a checkbox for remember me, and another button for sign in. Those are two behaviors, a checkbox and an event stream. Every time you click, you get an authentication and so on, and that's built in for you in the language. And finally, there's server-side sharing as a primitive. You remember how I showed you mailing out a URL for authentication for the email case? Well, the same way, sharing a spreadsheet with Eric should be just as simple, and that's a primitive. And finally, you can reflect on the policy, which means if I want to make the color gray because you have read privilege, but I want to make it white because you have read and write privilege, that's something that you get for free because you just percolate through the colors, you write a conditional in the color, whenever the color changes, things change. So a pop quiz for you is, what is an access control policy? Well, an access control policy is another time varying value. Right? Say Eric and I are sharing something, and Eric decides, I don't want to trust Shriram, right? If I give Shriram access to my spreadsheets, he'll put bananas in there, right? So he doesn't want to give me access, so he changes the privilege. Well, the change in the privilege percolates the server. That change percolates down to my client, which, because my code depends on the access control policy, automatically turns the writable cell unwritable and the white background into gray. And this is all built into the language. Okay? So this is the language Flapjacks, and I am supposedly out of time, so at this point I'm going to stop my talk. Just pointing out that what I've given you now is two stories. One is about synchronous applications that use continuations. The other is about asynchronous applications that use this language called Flapjacks, which is basically JavaScript. And what we have not yet done but will be working on is the synthesis of these two ideas. The problem is Gilad and William Cook are half right and half wrong. They are half right in that continuations are overkill. It's ridiculous to use and generate a new continuation for every little mouse click on your page. They are wrong in the sense that it does make sense for applications to be synchronous. Even Google Mail, for example, now lets you go back and forth. You can go create a search. When you're done with the search, you hit the back button and you go back to where you were. Okay? So it makes sense to have high-level synchronous views and low-level asynchronous views. The continuations are overused, but it's wrong to say they shouldn't be used at all. What we're working on is a synthesis that lets you have both. Question, Eric?
Yes, so this all very much reminds me of Fran and something that was in IE5 called active animation. But that's kind of led nowhere. So do you think that Flatjacks will suddenly kind of...
So I don't know. I can't tell you why IE5's things did or did not work. In fact, when I did my job talk entirely using IE5. I use COM to connect to these things. So I like that. I don't know what happened to it, and you would know better. Fran, I don't know what that is. Sounds like some sort of functional stuff because it begins with F, which means that's probably why it didn't work. And this is JavaScript, man. This is JavaScript. What is all this functional stuff you're talking about? I've never heard of it. Yeah. Question. Oh, oops. Somebody may have noticed that. Oh, well, it's too late now. Yes. Did you have your hand up?
I ought to.
Yeah.
I think I just wanted to comment that I don't think that being able to use the back button doesn't require you to use continuation. So there are plenty of apps that have full ability to go back to pages without using continuation explicitly. And so with that, because the whole idea of models as...
So let me just summarize that for the record. So Will's pointing out that going back is not the same as using continuations, and that's fine, but I think I'm trying to make a stronger point about the use of continuation, but that's okay. Yeah. Models.
Flapjack's a pretty interesting idea. Models are time varying, and you can essentially put a functional connection between two models is good. And I think the key point I wanted to make, though, is that it's a good illustration of something that I think a lot of people are not aware of, that you can have a declarative specification that is about something that is imperative.
Bingo.
And that's very
Bingo.
important.
So summarizing, you can have a declarative specification about something that's imperative, and I feel like I'm finally there. Okay, this whole business about functional programming versus imperative programming, conflict without a cause. The world is functional, the world is imperative, specifications can be functional, and we can all get together. Last question. Sir, Roman.
Okay, I think as I was watching it, I was trying to remember, I think I've seen it somewhere, and definitely I did. It's classical construction and interpretation of computer programs. They give a whole...
You've seen what before? I showed a lot of stuff. I like to think I should.
Stream-based computations.
Yes.
Yes. They give the whole chapter and build a very nice examples on stream-based computations. They talk about excluding time, excluding state, and everything based on streams. But then they suddenly, at the end, they stop and say, okay, now reality strikes back. You actually cannot avoid time, and in actual in applications, you have to deal with time when you have to synchronize these streams. And then the whole ugly reality is back.
So what Roman is pointing out is that stream-based computing is not a new idea, and I never claimed to invent it. In fact, I think it's been around since even before I was born. Yeah.
I'm asking what you're going to do when reality strikes back.
I don't know. What is reality? We have working applications. We have a programming language. We have a semantics, and I can tell you what...
to synchronize streams.
We have no trouble synchronizing streams. For example, let me give you a very quick illustration of how we did it, okay? So you remember the delicious demo where I move a mouse over and the thing expands, I move the mouse off and it contracts? There's one stream that represents all the mouse in events, another stream that represents all the mouse out events, okay? And I have a merge operation that lets me merge those two streams and produce the final stream that tells me what to do at that particular cell. So in fact, what I have is a time varying value sitting inside my HTML web page. Okay? I don't really see a problem there. But if there's a more detailed question, I think we should take it offline because Jim really needs me to finish up. But thank you very much.